Okay, today we will see solution by variation of parameter for the Euler-Cauchy equation. This one is in non-homogeneous form. So to solve this problem, first what we have to do is applying the differential operator, as you can see here. So if you apply, you will have x squared d of y plus x d of y minus 9y equals 48 x to the power of 5. So this is nothing but simply x squared second derivative of y plus x into first derivative minus 9y equal to 48 x to the power of 5. So now we can good to go. So we have the homogeneous part here. So first, in the first step, we solve the homogeneous part, okay? So when we solve the homogeneous part, what we have to take is this one. So to find the homogeneous solution YH, we have to find the characteristic equation. So x squared second derivative of y plus xy first derivative minus 9y is equal to 0. So as you can see, this is the non-homogeneous equation of Euler-Cauchy theorem. So let us assume the solution of this equation is y is equal to x to the power of m. Find its first derivative. It will be m x to the power of m minus 1, right? If you find its second derivative, it will be m into m minus 1 x to the power of m minus 1 minus 1, which is m minus 2. Substitute back this into the original equation, which will be x squared m into m minus 1 x to the power of m minus 2 plus x into y, our first derivative of the solution x to the power of m is m into y x to the power of m minus 1 minus 9 times the one we assumed originally is x to the power of m, which is equal to 0. So we can simplify this because the base is the same, so that the exponent will be added. M into m minus 1 x squared m minus 2 is x to the power of m plus m into x, we have 1 here, m minus 1 will be x to the power of m again, 9 simply x to the power of m is equal to 0. So you have similar terms here, so you can cancel out because the equality is 0. So our characteristic equation will be m times m is m squared minus m into minus 1 is minus m plus m minus 9 equal to 0. So our final characteristic equation is m squared minus 9, as you can see. So if you simplify this, this is m minus 3 into m plus 3 is equal to 0. The difference of two square. Okay, so it can give you this. So m1 is 3 and m2 is minus 3. So from the three cases, we use the two real distinct solution. Since our solution is two real distinct solution, we can apply the homogeneous solution will be c1 y1 plus c2 y2, in which our y1 is x to the power of m1, which is 3, y2 is x to the power of minus 3. Okay, so our solution becomes c1 x to the power of 3 plus c2 x to the power of minus 3. This is our general homogeneous solution for the homogeneous part of the Euler-Cauchy equation of this problem. But we have to solve for the particular solution of this non-homogeneous equation. We can solve it in two ways, in two options. We have two options. The first option is to assume the solution of the given general second order Euler-Cauchy equation. So if we assume, or let me rewrite my original problem. This is our original problem, okay? So to find the particular solution YP of non-homogeneous equation of Euler-Cauchy problem. It is better to say problem. Let us assume y equal to how much? Let me cancel this one here, because it is not enough. So we can assume from the undetermined coefficient, from that concept we can assume our value of yp. Let yp equals cx to the power of 5. Okay, find its first derivative. It will be 5c x to the power of 4, right? 5 minus 1. How about its second derivative? 4 times 5, which is 20, c x to the power of 3, 4 minus 1. Okay, let us substitute this into this equation. Okay, if we substitute into this equation, it will be x squared 20c x to the power of 3, right, plus x times yp derivative is 5c x to the power of 4, plus 9 times y minus 9 times y minus 9 times c x to the power of 5, which equals 48 x to the power of 5. Okay, but do you have terms which is similar to this this equation? Can you check? We have no similar terms to this equation, right? Can you find similar terms? Okay, let us you can't decide now, but you have to simplify it first. If you simplify it, we have x squared, we have x cubed, it becomes 20c x to the power of 5, plus we have x to the power of 4, it becomes 5c x to the power of 5 minus 9c x to the power of 5 equal to 48 x to the power of 5. All are similar. Okay, and we have constant coefficient. 20 times c is just c star. which is 20c, it can be 5c, it can be minus 9c. Okay, so this is constant, it is nothing but constant. C is constant, the number beside it is also constant. So 25 minus 9 is what? 60. C x to the power of 5 equal to 48 x to the power of 5. If you go for C, it is by 4, 60. Okay, how much? Sorry, it is 3, right? By 61, I'm sorry for the inconvenience. By 16, 1 by 16 is 3. 48 by 16 is 3. So C will be 3. Okay, so we have yp equals finally 3 times x to the power of 5. So our general solution will be y homogeneous plus y particular, that is C1 x to the power of 3 plus C2 x to the power of minus 3 plus 3 x to the power of 5. This is our general solution for this given Cauchy equation. Okay, for our problem, this problem, the original problem. Let us apply the second method, okay, using the worskian. Okay, so if we apply the second method, we have already the homogeneous solution. We have the value of y1 x to the power of 3 and the y2 x to the power of minus 3, don't forget. Okay, so if we use the worskian of y1 y2 the determinant y1 y2, it is matrix y1 derivative y2 derivative, so it is determinant will be nothing but y2 derivative y1 minus y1 derivative y2. This is nothing, we have y2, so its derivative will be minus 3 x to the power of minus 4, right, times y1, the y1 is x to the power of 3 minus y1 derivative is 3 into x to the power of 2 times y2 is x to the power of minus 3. Sorry, y2 is x to the power of minus 3. Simplify this, it will be minus 3 x to the power of minus 1 minus 3 x to the power of minus 1, which will be 6 minus 6 x to the power of minus 1. This is our worskian. So from this solution by variation of parameter, solution by variation of parameter concept, you have the y particular minus y1 u plus y2 v. What is v and u here? Our v and u is given by u is the integration of r of x times y2 divided by f of x times the worskian. we know that f of x second derivative plus p y derivative plus q y equals r of x. Okay, so as you can see, this coefficient is f of x, and the one after equality of equality is r of x. Okay, so we have here r of x, we have f of x. Okay, so and the v is given by the integration, again r of x, nothing will change, only y2 become y1 here, divided by f of x times r of x with respect to x, right? It will be integrated with respect to x, with respect to x. So let us do the integration by substituting everything we have. R of x, our r of x will be 48 x to the power of 5, and our f of x will be, you can say anything, h of x, g of x, so it will be x squared, right? So if we substitute everything, r of x is 48 x to the power of 5 times y2 is x to the power of minus 3 divided by f of x is x squared, and w is minus 6x to the power of minus 1. Look, we have 48, we have minus 6, which is constant, minus 48 over 6 integration x to the power of 5 x to the power of minus 2, which is x squared minus, let me cancel what I have simplified. We have also simplified this one here, x squared minus x squared times x squared the power of minus 1 means is 2 minus 1, which is 1, so here minus 1, so you have x here with respect to the x. Okay, because here it is 1, so if we put it up, we pull it up, it will become 2 minus 1, which is x. Okay, so 48 by 6 is how much? Eight, right? Minus 8 x squared over 2, which is minus 4 x squared. Okay, minus 4x squared, you have minus 4x squared. Then this is u. How about v? Our v will be integration, nothing will change, just y1 will change, so it will be 48 x to the power of 5 times how much? y1 is x to the power of minus 3, oh, x to the power of 3 positive, over f of x is x squared times the worskian is minus 6 x to the power of minus 1 with respect to x. So 48 again over minus 6 integration, this is 8 x to the power of 8 minus 1, because 2 minus 1 is 1. If we pull it up, it will become x to the power of 7 dx. This is minus 8 over 8, right, plus 1 x to the power of 8. This equals minus x to the power of 8. Okay, don't forget. So this is our v. So our final solution will be this one. Substitute here. If we substitute in yp is minus y1. y1 is how much? Minus x cubed u is how much? Minus 4 x squared, right? Plus, how about y2? y2 is minus x cubed, x to the power of minus 3 not minus x cubed, it is positive x to the power of minus 3 times v is minus x to the power of 8. Okay, so if we multiply this, it is positive 4 positive 4 x to the power of 5 plus, if we multiply this, minus x to the power of 5, which is 3 x to the power of 5. Yes, which is the same as the one we find here, okay? So it is the same solution, as you can see. So you add this to the homogeneous solution, then our general solution will be the same again. Thanks for watching. Please subscribe and hit the like button for more videos. See you.